Section 13.1 Inference on the slope of the regression line. Now we're talking about the regression line. The regression line coming back to us, we already learned in chapter 4. And in this section, we focus on the slope. Let's recall the notation. We have sample and population. The intercept for sample is B0, the slope is B1. For population is B0, beta 0, and beta 1 for intercept and the slope. We look at the example. If we're talking about the weight and the height of the people in the whole world, we have billions of people. So let's assume that the data are like this. This one is including the young, the old people, female and male, everybody. Okay, so let's say we have billions of data. We can draw the model line, and this model is the one that gives us the smallest amount of the square distance, which is the residual. The point right here that we got is beta 0, which is the intercept. The equation is y equal beta 0 plus beta 1x. And of course, it's very difficult to measure the weight and the height of everybody in the world. So we will focus on the slope, which is beta 0. How can we have an idea of estimation the B0, the B1 in a very good approximation? We will take a sample of 20 or 30 people. For example, in this case, I will take like 20 people. And we can draw the regression line using technology. And let's assume that we have something like this. So this is y hat and is equal to B0 plus B1x. For B0 is the y-intercept. What if we take another 20 people? Different 20 people. And we will get like this. So y hat equal, I'm going to call A0 plus A1x. For A0 is the y-intercept. Of course, the A0 and the B0 will be the same, and the slope of the first line and the slope of the second line are not the same, but they are very close. So based on the slope of the sample, we will have the estimation for the slope of the population. And we can do that. We can construct a 95% confidence interval to approximate the slope of the population, or 90% confidence interval. And also we can perform the hypothesis testing for the slope. We will do that later in the other video. So in order for us to do so, the confidence interval and the hypothesis testing, we need to have some assumption, and we need to check the assumption also. We have 3 assumptions. Number 1, the mean of the y values within the strip. The notation is mu of y of x. The mean, that means we average the y value of the population. The value have to follow the straight line. Mu equal beta 0 plus beta 1x. Number 2, the amount of vertical spread is approximately the same in each strip, except perhaps near the ends. Number 3, the y values within a strip are approximately normally distributed. This assumption is not necessary if the sample size is large. That means we take more than 30 sample size. In order to check the assumption, we will check with the residual plot. We will recall how to construct the residual plot in the Excel later. Number 1, the residual plot must not exhibit an obverse pattern. What does it mean by obverse pattern? That means it will follow a shape that you can able to tell. For example, parabola or a linear. So this is called obverse. Not obverse, that means they are everywhere, every places. The vertical spread of the points in the residual plot must be roughly the same across the plot. And number 3, there must be no outliers.